All right. Welcome back, everyone. Um, JP just sent me over a few questions. So, JP, if you're there, we can get back going with those questions and then get moving into the third hour.
Yep, I'm here. Hi, Kyle. Uh, so the first question I actually have for myself,
Yeah.
uh, because we've been getting a lot of questions both in the Q&A, by email, and in the chat, and that is whether this session will be recorded, and if so, will a recording be made available? And the answer to both of those is yes. This is being recorded. We will have the recording available sometime in the next couple of days. And for all registrants, we will send out an email to you as soon as it is up online. So you'll get an email in the next few days from Assistan. We will also put it up on our site, and I'm sure Kyle will be happy if he reached out to any of you individually with the link separately to join the webinar. And I'm sure you can get in touch with you with the recording there.
Yeah, once the video is ready, I'll probably tweet out the link as well if you do follow me on Twitter, or you could look me up there too, and I'll post it to the GitHub page. So you'll be able to find it there too.
So there are a couple other questions I think really specifically for you.
Yeah.
The first one is, are there any tools for merging multiple years of data as kind of a compromise between the 1 year and 5 year estimates? So that way you can get more current data than the 5 year data would provide, but with a smaller margin of error.
You know what you can do, at least out of the box, there aren't tools for that. What you conceivably could do, however, is grab data, say, for a couple years, for say the 2018 and the 2019 1 year ACS, and then use the functionality that's available inside of Tidycensus to calculate, say, an average over those 2 years, and then a derived margin of error, which will be a smaller margin of error than what you would have, say, for 2018 or 2019. And it would just be important to interpret that appropriately. This is the average value between these two ACS years. This is the derived margin of error, based on the formulas provided by the Census Bureau. Again, out of the box, that's not something that I know of that exists, but you could reasonably use that approach. One thing that I should mention, though, and this is fairly important, I don't have functionality built into Tidycensus to pull multiple years of data at a time, and that is intentional. The reason why that's intentional is because although variables do not change between ACS years in the detailed tables, they can change in the data profile or some of the other derived data sets. And so if you're not careful with this, for example, DP020068P in the 2015 to 2019 data profile is percent of the population age 25 and up with a bachelor's degree. In the previous 5 year ACS, it was 67, not 68. And so if you had tried to combine, you'd be working with different information. And so there are ways, and I've seen multiple people even come up with their own functions for doing multi-year ACS analyses. Just exercise caution and just double check that that your variables align. Another issue that does come up in the detailed tables is in early versions of the ACS, there were fewer sort of combined tables than there are now. And so sometimes you might look for a variable that exists in the most recent ACS and you go back 10 years or even 5 years and it doesn't exist in that data set. So just a couple of things to be mindful of when you're doing time series work.
Right. So you provided the perfect segue into another question. We've had multiple people ask about, as you said, earlier versions of the ACS. We've had multiple people ask about, will the R package, will Tidycensus provide ACS data before 2005?
The ACS only goes back to 2005, so that's as early as we have. You can get 1-year ACS data going back that far, and you can, but the earliest you can get 5 years is 2005 to 2009. You can get earlier data from the decennial census going back to 2000. We used to support 1990, but census took down the 1990 API. I don't have a timeline for when they're going to put that back up, but when they do, we will support it. Earlier than 1990 is not, I believe, is not a high priority for the Census Bureau. I have heard that to provide in API form. So Tidycensus will not likely go earlier than 1990, and right now it does not go earlier than 2000. NHGIS is your solution for historical work. They have put in the grunt work of assembling and harmonizing those data sets. And for any historical researchers who really do need to go back, that's where you should look. They are actively working on programmatic access to their data. If you kind of want to have that R-based workflow, but be able to get that historical data, the IPMS R package is a good place to look, and they have staff that are actively working on improving that interface all the time. So that would likely be your solution.
And one last question. This one is focused on the educators.
Yeah.
So if you were teaching undergraduates, would you start with base R, or would you feel comfortable starting with tidyverse and skipping base R?
Wow, that's that's actually kind of a loaded question. Some of you who are in our community might know. This has been the subject of some fervent debates. I sort of skirt the question because I teach Python to my students. I don't actually teach R at TCU, just for reasons. I'm an R user, but a Python teacher. And that's because Python is really an essential skill for geography students. And so that's why I go that route. I would personally go with the tidyverse. That's what I would do. That would be my approach. It is based on my personal experiences, and that's not necessarily going to be right for every application. But thinking about the types of work that I do, I tend to teach and work in areas of exploratory data analysis and also spatial data analysis. And the SF package, which allows you to do all sorts of interesting GIS work in R, integrates extremely well with the tidyverse. Base R is extraordinarily powerful. It's continuing to get better. I think once you get to a certain point with R, it is helpful and important to know how to use it. And if I were teaching that, I would incorporate in, the most important pieces as I went. But if I personally were teaching an intro to R course, it would likely be tidyverse centric. Part of that is personal bias. That is, really how I gravitated toward R. I was not much of an R user before the tidyverse. That's really what resonated with me. But at the same time, there are a lot of other frameworks that are very, very powerful and very useful. A lot of people do very, very well with base R, and there's a whole lot of knowledge and, an infrastructure behind that, and that is a perfectly reasonable way to go. And also, a lot of people use the data table package for data wrangling and manipulation, which is very fast and can do really a lot of things. I'm not personally a data table user, but that's not anything against the package. It's just because I sort of learned R through the tidyverse.
All right, great. Thanks for those. And turn things back over to you for the third hour.
Excellent. So let's delve right in to data visualization. And to JP, to your previous question, part of the reason that I would teach with the tidyverse is because of ggplot2, the ggplot2 package for data visualization, which integrates just directly integrated within the tidyverse. And it's interesting, I teach a class on called analysis and visualization at TCU, and it gets students from all over campus. I'm in the geography department, but our program is small, so we teach a lot of students from business, communication, some of the bigger colleges on campus, and they come to my class to learn core data skills. And the class is taught in Python, and it's generally taught to non-programmers. The expectation is not that you come in with a programming background. The expectation really is that you're kind of going to learn from the ground up. And where all this stuff really starts to click is when data visualization is introduced. So I try to introduce that really as quickly as possible. We get the nuts and bolts of Python down, and then we start making charts, mostly with Seaborn. And visualization, I think, as all of you know, is an extraordinarily powerful way to communicate information that might be complex or difficult to understand for a non-specialist population. And, in many cases, when we're working with census data, visualization is where you're going to want to go first. You could be showing some of these data tables that we looked at that say, hey, it's interesting. These are the youngest and oldest counties or county equivalents in the country. But even a table of data is not always the easiest thing to parse, because, a bunch of numbers up on the screen, you're sort of cognitively trying to kind of think about what's the difference between this number and this number. Visualization can help resolve a lot of that. And so we'll spend the rest of our workshop today going through some recommended paths for visualizing US Census data, how to make your charts look nicer, and how to, even at the end, create some very creative charts that are a little bit more advanced but kind of fun to work with. So we're going to be delving in more to ggplot2, and ggplot2 is the core framework for data visualization in the tidyverse, which I mentioned before. And there are a ton of extensions to ggplot2, which allow you to create everything from the most simple charts. And I tell my students this all the time: simple does not mean bad. It doesn't mean you don't know what you're doing. Simple is often the most effective type of data visualization. But also, if you have a need for or want a complicated interactive plot, ggplot2 based extensions can facilitate this too. So we're going to look at that in just a moment. So let's walk through a variety of different examples. Let's say we want to compare ACS estimates. In this particular case, we're interested in the percentage of commuters who are taking public transit to work in the 20 most populous US metropolitan areas. So a few things that will be incorporated in here that you've learned in the previous 2 hours of this workshop. We're loading in Tidycensus in the tidyverse package. Just as a heads up, tidyverse, the package, is actually what's called a meta package that loads in a bunch of other packages. So in this particular example, ggplot2, the visualization package, dplyr for data wrangling, those are all loaded in when you do library tidyverse. So I'm creating a new object called metros, and let's just take a look at what we're doing. We're grabbing, using getACS, geography equals CBSA. CBSA stands for core-based statistical area. You can think of that as either a metropolitan area or a micropolitan area. It includes both. Sort of regions as defined by the Census Bureau around a core or cores, so a relatively populous city. The variable we're going to grab is from the data profile, the percentage of the percentage of commuters taking public transit to work. We're going to use a summary variable from the detailed tables that grabs total population. We'll use the 1 year ACS here, and then add a little bit of tidyverse data wrangling in here, in which we're saying, in descending order of total population, the summary estimate, give me back only those metros where the rank is less than 21. So that's our top 20 metros by population. Let's jump back over to R and take a look at what we get. I'm actually going to restart R real quick. You don't have to do this, but I'm going to do that to clean out my environment. So I pull in this data for metros. And I also, the reason why I restarted R is I wanted to show you this. When you load in tidyverse, it shows you all of the packages that are brought in. These packages, ggplot2, dplyr, and then some other packages that are used for data manipulation. So now I have my metros data. A handy function for just taking a quick glimpse, so to speak, at your data is the glimpse function in the tidyverse. What we can do is, we've learned how to do this already and just print out our data. I type metros and I can see, the metros in that capacity. Here's Atlanta with an estimate of 2.8 and the margin of error is 0.2. These are our top 20 metros by population in the US. The glimpse function shows you your data, but in a different format. So it prints out all of the columns as rows as displayed here, and then lets you look at the first few values. So one is not necessarily better than the other, but I wanted to make you aware of the glimpse function to take a peek at your data. It can be very helpful. So here we have a bunch of information. We have the GeoID, we have the name, we have our variable, and then an estimate. And we can kind of take a look at this and see what's going on with respect to the proportion of the population that's taking public transit to work. So let's try plotting this information, a first plot. And we can take a look at this back over in the slides as well. We have here some syntax that allows us to specify our plot. And so if you're not familiar with ggplot2, let me walk you through this very briefly. I'm creating a new plot object, which isn't strictly required, but I'm doing it here for purposes of illustration by calling the ggplot function. And the ggplot function creates a plot instance for you. It's basically a blank plot. And then what you do is you specify an aesthetic mapping for a given data set. So our data set is going to be metros, and then we use the AES function to specify an aesthetic mapping. I'm mapping the name column to the x-axis, the estimate column to the y-axis. And if I wanted, I could map other data to various other aesthetics, like the object fill or the color or other characteristics as well. ggplot2 is based on the philosophy of a layered grammar of graphics, and then you can layer different components one by one onto your plot. I then specify geom_col. This is the geometry, the shapes that I'm going to draw. And this plot is going to give me a bar chart in which the length of the bars are going to be proportional to my numeric column, which is here the ACS estimate. So let's take a look at what we get. We have here a chart of the percent of taking public transit to work. It is not legible at all. It's kind of it's a naive plot in this capacity. However, we can see that, okay, here's one bar that's really, really high for New York Metro. We know that's New York. We have some other cities here. The name is totally jumbled. I can't even see it at all because it's all mashed together. I didn't really think about in this example how I needed to format my plot. I just made a plot. But that doesn't mean this plot isn't useful. It allows me to see some of the variations that I have in my data. I can't really understand what it corresponds to, but now I can think about, okay, I have this as a starting point. How do I move on from this and improve? So this is something I do. It's one of my first visualization exercises I do with my students in my classes. I say, okay, if you're going to improve this, what do you need to do? Well, we should move the names of the metros to the y-axis and the estimate to the x-axis and draw a horizontal bar chart instead of a vertical one. Another thing we should do is sort our data in descending order, sort our bars in descending order so we can make comparisons. And part of the reason that these names are so messy, if we scroll up here, is these metro names are very, very long. And I live in Fort Worth, Texas, and it pains me to do this. But when we're making really precise comparisons in a chart, it probably makes the most sense to call the Dallas-Fort Worth Metro just Dallas, because that saves space on our chart. And so what we're going to do here is we're going to cut off this name column either at the dash or at the comma, and remove everything else behind that. So this is something that is a little bit beyond the scope of what we're talking about today. We're using what's called a regular expression here, but I do want to make you aware of the string R package, which is part of the tidyverse. It includes all sorts of functionality for string manipulation. And so what we're doing here is we're cleaning up that name column. We're saying remove everything after the dash, remove everything after the first comma that you find. And then notice in our aesthetic mapping here, we reorder the name column based on the estimate. Let's see what plot we get back now. That's a lot better. We've cleaned up our metro names. We've sorted in descending order. And now we can clearly make some comparisons. So by far, New York has the most transit commuters, San Francisco, Boston, Washington, that's expected. Detroit, Dallas, Tampa, Riverside, those metros, fairly small proportions. So now we can actually start to have some conversation about what's going on. And this is helpful. Again, if you think about a chart like this versus showing someone a table of information like this that we print out in our R console, this is a lot of information. It's a bunch of numbers. We can't necessarily easily compare some of these values that are very close to each other. The visualization allows the kind of display of this information in a way that's going to be digestible to most of your audience. People can compare proportionality of bars. They know that New York is more than San Francisco because the bar is longer. Now, you probably want to make some additional modifications, however, to your chart and get even a little bit cleaner. And so ggplot2 has a bunch of different themes baked in. My personal favorite is theme minimal. I think everybody you talk to who uses ggplot2, they've got their own favorite theme. Theme gray is the default. I like theme minimal the best. So I'm specifying a theme minimal, and then I use the labs function to specify a title, a subtitle, axis labels, and then a caption to cite my sources. So you'll notice in ggplot2, the different methods are chained together with the plus sign, not the pipe operator. And I know Hadley, Wickham, and the staff at our studio have talked about this. It's in part because ggplot2 precedes the introduction of the pipe operator, but you can think of these working the same way. So you're taking basically your plot, and then you're giving it a new theme, and then you're layering on some different labels. And now we can run that through, and let's take a look at what we get. Make this a little bit bigger so we can see it. It's a much cleaner representation. So we've got a white background, some minimal grid lines. We have information about what we're seeing. These are the 20 largest metropolitan areas, percentage of commuters who take public transit to work. All right. So hopefully that gives you a little bit of a sense of what you can do visually to take your ACS estimates and start to make some comparisons with them. Now, something that during the break, I was browsing through some of the questions, and I saw one question along these lines that I thought, well, this is great. We're actually going to talk about this. And the question was, is there a visualization technique for dealing with margins of error? It's very difficult to explain what a margin of error means to a non-specialist audience. Even to a specialist audience, it's not always the easiest. And if I'm saying that margins of error matter, that they're important for you to know about, and then you're communicating information based on ACS estimates, should you incorporate those margins of error into your visualizations? I'm going to show you an example of how to do that. When you're dealing with large metros, that say have 5 million, 10 million people living there, the margins of error around your estimates are going to be fairly small. But when you're dealing with smaller geographies, with smaller populations, margins of error can be quite large. And in turn, making comparisons of estimates that have large margins of error requires a little bit more detail, a little bit more nuance. And so we're going to spend some time talking about that. How do you visualize margins of error in the American Community Survey? So let's grab some data to take a look at this. We're going to take a look here at median household income, so a familiar variable for us at the county level in the US state of Maine. We're going to use our string remove function to lop off the county Maine that is appended to the name of all of the counties. Given that all of the counties are in Maine, we don't need this information. And so let's take a quick look at this data. I'm going to first pull the data in, and then we'll take a quick look at it. So here we have the counties in Maine. There's 16 counties in Maine. We have the median household income by county, and then we have the margin of error around that estimate. You know, in those cases, the margins of error are not massive relative to the estimate like we see in, say, census tract level estimates, but some margins of error is certainly larger than others. We can use the arrange function to take a peek at this. You know, which counties in Maine have the largest margins of error around their estimate, which have the smallest. So I'm going to run through this code here where I'm arranging my income information in descending order of margin of error. So let's take a quick look. We see here that there's pretty wide variability in terms of the size of the margin of error around the different estimates. So in Lincoln County, the margin of error is around $3,200 around the estimate of $57,720. On the low end, say Cumberland County here, we have an estimate of 73,000, but the margin of error is much smaller. So we have greater confidence of where that point estimate actually falls. And so when we're making comparisons between these different counties in Maine, we have to acknowledge that there are going to be some small rural counties in which the margins of error will be larger. And there are going to be some larger, more urban counties like Cumberland County, where Portland is located, where the margins of error are going to be smaller because we have more people that we can draw from. And so a question that often can arise, and it was a great question that was asked by one of the participants of this workshop, is how do I visualize this information? What I recommend doing is creating what I call a margin of error plot that is shown here with this MOE plot code. So if we go back over to the slides, we can take a look at how to create this. What I'm doing is using some familiar ggplot2 syntax here. I'm creating a plot where the data is coming from my main income data set. My aesthetic mapping is my ACS estimate goes to the x-axis. My sorted in descending order name of the county is going to the y-axis. So it's a similar aesthetic mapping to what we used previously. I'm then using a couple different geoms here that I'm going to layer on top of one another to illustrate margin of error around the estimates. I'm using the horizontal error bar geometry, where the aesthetic mapping is give me the minimum x value is the estimate minus the margin of error, and the maximum x value is the estimate plus the margin of error. Layer then the actual estimate as a point on top of that and make the color dark green so it pops out. We then specify some informative labels, and then we use the scale x continuous function to format our median household incomes as actual dollar values. So let's take a look at what we get when we run it. Here we have a margin of error plot. You can call it maybe a TIE fighter plot if you're a fan of Star Wars. It kind of looks like a fleet of TIE fighters that are organized in this case in descending order. Cumberland County is the wealthiest county as measured by median household income in Maine. That makes sense as the large city of Portland is there. And we can see here, we have the point estimate, and then we have the margin of error around that estimate visualized on this margin of error plot. This allows us to think about some of the nuance in terms of ranking these different counties. For example, we can be fairly confident that Cumberland County has the highest median household income of all counties in Maine because its margin of error does not overlap the margin of error range of York County, which is the second richest. When we start getting into the middle here, we need to start interpreting these estimates with nuance. For example, we see here Hancock County. Hancock County has a margin of error around the estimate. The estimate suggests that Hancock County has a lower median household income than Lincoln County and a higher median household income than Kennebec County. However, given the range of the margin of error, it's reasonable that the actual estimate, the true value, I should say, the true value of Hancock County could actually be higher than Lincoln County, but also higher than Knox County, though it could also be lower than Kennebec County. So hopefully this isn't making your head hurt too much and thinking about, okay, I'm trying to make comparisons here, and you're telling me that it could actually be higher than this county, it could be lower than this county. Well, given that the data that we have are based on a sample, that is accurate. And this is a way that we can start, however, interpreting our ACS estimates. We're saying here, yeah, we do think that this is where the ranking is with respect to incomes, household incomes of counties in Maine, but it's important to understand that these estimates are characterized by uncertainty, and you can see the range of the uncertainty around these estimates is visualized in this margin of error plot. I find this to be a pretty useful visual heuristic for thinking about and showing people how and why margin of error matters and impacts your downstream data analyses. All right, so let's start getting into some more advanced charts that are kind of fun to work with that Tidycensus facilitates. And ggplot2 is doing the heavy lifting here, but my goal at the beginning developing Tidycensus was in many cases thinking about in my research, in my teaching, in my professional work, all of these visualizations that I want to use on a regular basis. How do I get there faster? As you know, as data analysts, the data wrangling process to get data in the right format for the right visualization, that can be fairly laborious. And so ideally, we can make creative visualizations with not a whole lot of data wrangling code. There's always going to be some of it because you want to make sure that you're removing the chart junk that you don't need and that you're clearly expressing what you're trying to express. But we'll show you kind of some examples here of how you can make some fun visualizations that you'll be able to take away after this workshop and play around with. So let's take a look at population pyramids. Population pyramids are one of the most popular visualizations for looking at the demographic breakdown by age and sex of a population. And we're going to use a new function in Tidycensus to get data for these population pyramids. We're going to use get estimates to talk to the population estimates program API. I added this in 2018 to Tidycensus. Originally, my plan was just decennial census and American Community Survey. That's all it's going to do. The Census API package is great. It already does all of these other APIs, and I still do feel that way. But I wanted to add get estimates with the population estimates API because I felt like the data that were coming back were very much aligned with the broader principles under which I developed the package. So get estimates allows you to pull in different products that allow for some different demographic statistics that aren't necessarily found in ACS. So you can grab population estimates you can grab components, which is very useful and interesting. You can get births, birth rates, deaths and death rates, and migration. And you can get housing information and then also characteristics. And the characteristics product, which we're going to use here, is very handy because you can break down your data along a kind of variety of axes. So by race, ethnicity, and by age and by sex, and create really customized visualizations in that capacity. So let's take a look at what population estimates data look like. We're going to look at for the state of Utah, and we're going to grab characteristics. So this will give us population estimates broken down by sex and age group. We're going to use informative labels, and we're going to grab data for 2019. So let's go over to R and run that through and take a look. All right, so here's our data, and this is what it looks like. We have here a similar kind of structure to what you get back from, say, a get ACS or a get decennial, but a little bit different in that we have our breakdown groups associated with the different values. So this particular value, any given row, is a state, sex, age group combination. So for both sexes, age 0 to 4 years in Utah, this is the estimated population value. Now we need to do a little bit of cleanup here before we make a population pyramid, because this returned a couple elements of information that we don't need. The population pyramid is going to be a stacked bar chart that shows population values organized vertically by age and then mirrored around a central axis by sex. So we don't need the both sexes value, and we don't need the all ages group. So we're going to filter that out. And you can see here we're using the filter function to only keep those age groups that start with age, and we're getting rid of all of the sex values that are both sexes. We're then doing a little mutation here, where we're using a new function called if else here, which says if this statement is true, do this, otherwise do that. We're recalculating the value column such that if the sex is male, make the value negative. Otherwise, keep the value as it is. Let me show you what this gives us back. Now all the male values are negative. And why do we want to do that? In a population pyramid, as mentioned, the bars are mirrored around a vertical axis. So the male bars will go to the left and the female bars will go to the right. Once we've done this, we can make a first population pyramid. So flipping through here real quick, let's take a look at our ggplot code. Once our data are formatted the right way, we can make a population pyramid with a minimum of visualization code. My data set is my filtered Utah data. My aesthetic is I'm mapping the value column to the x-axis, the age group column to the y-axis, and now I'm using a new aesthetic, fill, and I'm mapping the sex column to the fill. So we'll get a different color of bar per sex. I use geom_call to make a bar chart, and let's take a look at what we get back. We have a population pyramid. What we see here is the largest age cohorts in Utah are age 10 to 14 years and age 20 to 24 years. And it has more of a traditional pyramid shape in which you have larger age cohorts on the bottom and smaller age cohorts as you get older. What's interesting about Utah, as opposed to really every other state in the country, and I'll show you this in just a moment, a traditional population pyramid, again, has larger populations in the younger years and then smaller populations in the older years. But population pyramids are effective visualization tools because the structure and the shape of the pyramids tells you about different demographics of different places. And Utah is somewhat unique in its maintenance of a traditional population pyramid structure. Most US states don't look like this because birth rates in Utah are noticeably higher than really in any other US state. And so it makes Utah a compelling example to use for a population pyramid. That said, as we talked about before, you're probably not going to be satisfied with this pyramid. We have a bunch of extra stuff that we don't need. For example, it says age in every single value here, and we probably want to get rid of that. Age group, I don't know how necessary that is. Value, that's not all that informative. And then we have negative values in the chart. So are we really, you can read this, you can say, oh, I think I kind of know what that means, but this is something that we want to clean up. Using a little bit more advanced code here. So this is something that you can play around with a little bit, but notice the different styling that I'm using and some of the different aesthetics that I'm using. So I'm creating my pyramid the same way, but note that I'm changing the width of the bars and I'm making my bars slightly transparent for aesthetic purposes. I'm changing to theme minimal and I'm using this base family argument to choose a new font. I specify in my axis formatter functions, you can actually write your own little functions. This is a little bit more advanced, but basically what's that doing? What it's doing is it's taking those axis labels and it's giving you back the result of the function. And so basically what I'm saying here is I want on my x-axis to divide this value by 1,000 and add a k onto it. And on the y-axis, I want to get rid of age or years. Let's run this through and see what we get back. We get a much nicer looking population pyramid, which has informative axis labels. It's cleaned up the tick labels over here, and stylistically, we got a little bit of transparency going as well. So now let's delve into some ggplot extensions and take a look at some more advanced chart types. The first one that I'm going to show you is Plotly. And if you haven't installed the Plotly package, I would do that now with install.packages Plotly, if you didn't do that at the beginning. The Plotly package is really fun. A few years ago, a number of really innovative developers created this package called HTML widgets, which brought interactive JavaScript web-based charting to R. And now there are just dozens of these packages that allow you to create really compelling interactive web visualizations using R code. This was really why I originally learned R, because I wanted to create JavaScript plots. Creating them from scratch using HTML and JavaScript was a little bit beyond my skill level at that particular point in time. This bridge between R and JavaScript was really, really attractive to me. And it's gotten better and better. The Plotly package has a function called ggplotly. All you have to do is take a ggplot object that you've created, like the Utah pyramid chart that we've made, and pass it to this ggplotly function. And check out what you get back. I run that through. I now have an interactive population pyramid. I can hover over any of the bars and I get back the actual data value. So for women aged 65 to 69, the population estimate in Utah in 2019, the population estimate is about 64,000. For men or for males aged 10 to 14, you can get back that exact value. Now, granted, I could do a little bit more cleanup as well in my data if I wanted to format that tooltip, but I just wanted to show you very briefly, with a single function and a minimum of code, you can convert over your ggplot object and your ggplot2 creation into an interactive chart that preserves most of the styling. And Plotly, it's not just about the hover tooltips. I can click to turn on and off different data series. Or if I want to, I can use this little zoom feature. Let's say I only want to look at older age groups. I zoom into this part of the plot. And now I have an above 50 population pyramid for Utah. I can double click and it takes me right back to the original plot. This is a lot of fun to play around with. I'd encourage you to try it out. The very last piece that we're going to take a look at for our workshop today is ggplot2 extensions. And ggplot2 is a phenomenal and customizable package for visualization, and it accommodates extensions where the community can come in and create new geometries that they can work with, create new functionality in ggplot2 that allow developers and analysts to create all sorts of interesting plots. GG Animate is maybe one of the most fun ones. I'm not showing that today, but I'd encourage you to take a look at that. It, in a very straightforward way, allows you to create animated charts. It's very, very fun to play around with. I'd encourage you, if you have the slides up, to follow this link and take a look at the extensions. A couple fun visualizations just as a takeaway from this workshop to look at. One that I really like is the bee swarm plot, which you'll see here. This bee swarm plot, it's called as such because it looks like a bee swarm of dots, but it allows you to see the distribution of values, in this case by category. So what we're showing here is census tracts in New York City. And it shows the household income distribution of census tracts in New York City by the largest racial or ethnic group in that tract. And New York City has a lot of census tracts that have a plurality or majority of non-Hispanic white, non-Hispanic black, non-Hispanic Asian, or Hispanic populations, which makes it a nice example for purposes of comparison. And so you can get a sense here of where, say, the median values are, where the values tend to cluster around. And we see how the distribution of plurality white tracts with respect to median household income differs from, say, plurality black or plurality Asian or Hispanic. But you also can take a look at the range and the variation, which is often lost when you're having conversations about, okay, what is the average value? In this case, there are some very, very wealthy white census tracts in New York, but also some lower income ones. You don't see the same level of sort of wealthy majority non-white tracts, but there are a number of census tracts for each that have a plurality, at least, of each group with median household incomes above $100,000. And so if you want to play around with that code, you'll need to install the GGB Swarm package and load it in, but you'll see how to create that code here. And it's created by using some of those tidyverse wrangling tools that we've looked at. The second fun plot that I want to show you is a geofaceted plot. And I didn't get into this today, but one of the most powerful methods you can use in ggplot2, in my opinion, is faceted visualization, where you're using that sort of group-wise data analysis paradigm, but applying it to visualization, where you're saying, I'm going to create a chart for each group. The geofacet package is really fun. It's an extension to ggplot2 that allows you to create plots. You might have seen these in the New York Times or the Washington Post or other publications. They allow you to create separate plots for a given value in your data set. In this case, we're creating population pyramids for each state, but it puts the panels, it puts the little plots in relative terms where that particular geography should be geographically. You're never going to get it perfect. I've seen this one used before, and I'm using this particular grid here because I thought it did a pretty nice job with handling where Puerto Rico goes, and it aligned a little bit better with the names that come out of Tidycensus. I've heard some people say, well, how can you put Wisconsin north of Minnesota? That doesn't make any sense. And I get it. There are a lot of different grids. There are international grids for those of you who work internationally. There are a number of different US grids, and there are even county grids. For example, there's a grid for counties in Michigan if you want to make sort of different plots for counties in Michigan. But this one is pretty fun. As I mentioned before, looking at the demographic structure, you see here Utah, which has a more traditional pyramid shape. You can compare that with places like Maine or Vermont, New Hampshire, which have older populations. Or you look at North Dakota here, which has this bulge, which is due to sort of, oil and gas workers who are coming to work in the oil fields. and move into North Dakota for those reasons. So interesting narratives, advanced visualizations that you can use and create with your Tidycensus data. So the code is available here for you. You need to install the GeoFacet package. If you want to play around with this, you're welcome to do that. All right, so a couple things, and this is sort of a takeaway, and we'll have a little bit of time to answer a couple more questions if we have them, but a couple exercises that you could do on your own time if you want. Pick a different variable in the ACS for a different location potentially, and create a margin of error visualization of your own. And try modifying that population pyramid. Play around with it. Use different colors. Use it as an opportunity to learn some of those advanced features in ggplot2, and try to customize that pyramid to your liking. All right, that's all I have for today. Thank you so much for those of you who spent the entire time here. If you spent part of the time here, if you are flipping through the video, I really appreciate your time. Bill, JP, everyone at Michigan, I really appreciate the invitation as well. And this isn't the end. We're coming back next week, same time, and it's going to be all about spatial data and spatial analysis. So if you're thinking, well, this visualization is great, but I really want to make a map, I need to make maps of census data, Tidycensus helps you do that. You're going to learn all about that next week. So thank you so much, everybody. I appreciate it.
Kyle, thank you very much. You know, I know all of the registrants and all the participants today really appreciate this great information. We certainly do at SSStan, and we really look forward to session 2 next Thursday, and then the third one on the 25th of March. This is a kickoff of our pandemic webinar series, I guess you can say, and you've really helped us a lot, and we really appreciate it. There's a lot of good information. I also want to put a shout out for another workshop we're going to have on March 18th with a different set of presenters, and that one will be focused more on undergraduate teaching using already put together course modules and data sets, and how you filter those into different topics in your classroom. But it's all part of our broader program of making teachers, giving teachers the accessibility of census and ACS data that they can use in their teaching and in their research. Want to see if John DeWitt has anything to say to end today.
I think you hit on everything. Some of the links are up on the screen right now. We will send out the links to both the slides and the resources that Kyle referred to during today's session, as well as a link to the recording once that is available. So all that will be coming to you in the coming days. Thank you so much for attending. Thank you, Kyle, for the great presentation, and we look forward to more of this later in March.
Thank you. I look forward to it. Hope to see you all next week.
Take care.